In this handout, we're going to talk about functions of several variables. Essentially, what we're going to find is when we were first starting to work with our functions, we worked with functions of one variable. For example, a revenue function where we sell X commodity. For example, maybe we're selling a shirt. They're $5 each. So we're given this function R of X equal to $5 times however many shirts we sell X, right? And so we have one input, just X. It is common that our functions, especially for example, this revenue function, depends on more than one input. We sell more than one thing, right? So we can sell an X number of shirts for $5, and then we can sell like Y number of pants for $12 each, right? And so what we have now is a revenue function that depends on selling an X number of shirts and a Y number of pants at, you can see those values there in the function, right? $5 per shirt, $12 per pair of pants, right? And then this is an example of a function with two inputs, right? X and Y. In our last example, right, we could sell X number of shirts for $5. We could sell Y number of pants for $12. Hell, we can add a third variable, let's say hats, for $10 each. Again, now we have our inputs, X shirts, Y pants, Z being hats. If I add up the total number of shirts for $5 each, pants $12 each, hats $10 each, right? We will get a total revenue function. This particular function has three inputs, X, Y, and Z, right? Three inputs, X, Y, and Z. And so for our multivariable, several variable functions, right, here's a definition, is we can have some number of variables, call it n, right? 1, 2, 3, 4, 5, all the way up to the nth variable. It is a rule that assigns each input, now we have multiple, to exactly one output is the ones we will be focusing on, right? So we'll take each one of these inputs, plug it into F, get some output, right? So here are all our inputs. Here is our rule, call it F. We will assign it to one output value. Any function that involves two or more inputs is known as a function of several variables or multivariable. And two alternative names. So for example, right, what we're going to have, let's kind of squeeze it in at the top here. Let's say my business sells 2 shirts in the first hour, let's say. Let's say they sell 1 pair of pants and 1 hat. So there's pants. If I wanted to know, let's zoom in just a little bit, my total revenue selling 2 shirts, 1 pair of pants, 1 hat, I'm going to plug it in on the next line, right? I'm going to plug each one of these values into my function. So 5 times 2 for X, plus 12 times Y, which is 1, plus 10 times Z, which is also 1, and then we're going to get one single output, which is our revenue. So 5 times 2 is 10, plus 12 plus 10. We have made a total of $32 in revenue, right? So what that brings us to is this notation plus how we use it, right? And so we have 2 different ways that we write the output. It can be written as Z or it can be written as f of x, y, right? It is pretty common that we use Z in terms of our output. I am actually a really big fan of this function notation output. You'll see probably me weigh a little bit more heavily on that. And what it's saying, right, is we're going to take our input, square it, we're going to multiply our inputs together, right? And so kind of keeping in mind that the first value is our x value, the second value is our y value, and we're going to plug them in accordingly. So what I'm actually plugging in is x equal to 1, so 1 squared, plus 1, and y equal to 2, so times 2 plus 2 squared, and then I get some output, so 1 plus 2 plus 4, which is 7.